Hello. We are continuing our study of Chapter 2, Descriptive Statistics, and we are focusing on measures of central tendency. Okay, so by now you've been introduced to the concept of a frequency distribution, and basically, as a recap, you have some quantitative data, and under certain conditions, you can describe the data by way of a frequency distribution. Okay, and you can graph a frequency distribution, and you can make line graphs and bar graphs, and they're all section 2.1 and 2.2 are both just describing ways to visually display data and distributions. So now we're going to talk about how to classify data. And one of the key things that you're looking for when you're classifying data is you want to talk about the center of the data. So you want to say where's the center of the data. Another thing is you want to look at how spread out the data is. What's the spread of the data? And last, you want to look at the position of the data. So the rest of this chapter, right? So chapter 2 is split up into essentially two parts. The first part is just introducing you to, so it's an intro to distributions. And the second part is describing distributions by way of the center of the distribution, the shape of a distribution, the spread of a distribution. Okay, and we'll put shape and position. Okay, so let's get started with 2.3, which is going to teach us about, we're going to learn about measuring the center of a distribution. So measures of central tendency. So we have three objectives for this section. The first is finding the mean, median, and mode of a population and of a sample. The formulas here are going to be exactly the same for whether you're finding the mean of the mean of a population or the mean of a sample. Same thing with median and same thing with mode. Most of you will have seen these definitions before. Okay, we'll get to some new stuff usually with this third objective here, which is describing shape of a distribution as symmetric, uniform, and for skewed, we've got kind of two options. Our options are going to be left skewed, right skewed. So just as a preview, left skewed means we've got a big left tail. So the distribution data is shaped like that. And then right skewed means we've got a really big right. Right, so we call these tails. Right, that part there is a tail, that part there is a tail. So left skewed and right skewed. And and then finding the weighted mean of a data set. This is something that we actually have done before. It's how you calculate your GPA. Right, it's how you calculate your grade in a course. Those are two examples of weighted means weighted means that we're used to computing. Okay, so we kind of touched on this before, but what do we mean by measures of central tendency? Here's the key thing. It's as if you wanted to ask yourself, what is one value that represents your entire data set? That's what you would call the center, right? And if you were to have one value to represent the data set, typically statisticians choose mean, median, or mode. Okay, so these are the three most common measures three most common measures of central tendency: the mean, the median, and the mode. And so we'll run through these really quickly. The mean is the same as the average. So essentially you just take all of your data entries, add them up, and divide by the number of entries. I want to point out to you this notation here, sigma notation. We've kind of seen sigma notation before. The sigma means add up everything, right? So we're going to use sigma notation here. So the formulas for mean are right here. So I'm going to highlight these formulas. So mu is equal to the sum sigma x over capital N. And then also we have for sample mean, x bar is equal to the sum of x over n. Now these two symbols are going to be so very important. You need to practice them right now. Practice saying them with me. Mu. Okay, that was crappy. Let's try again. Mu. 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 It's kind of like moo, but it's like mu. Mu. So it's pronounced mu. And then the second one here for sample mean, x bar. So it's x bar. So it's like x bar. Say it with me. X bar. X bar. Mu is the symbol for your population mean. X bar is a symbol for your sample mean. Okay? And you want to practice saying these because when you're talking about math and you're talking about statistics, you don't want to say, what's that little funny symbol? You want to be able to use the vocabulary, okay? So, let me just point out a little something. If I were you, and I really encourage you to practice with me, practice writing this symbol of mu. So mu is a Greek letter. Now, some people write it like a U. It's not a U, but here's the way to write it. It's write a U and then give it a tail. Okay? So you'll see me with that's a mu. That's mu. And here's how you spell it. M-U. Mu. And then for the x bar, that's a little easier. X and then bar. So we talked about before that whenever you have symbols and variables for your population, they're going to be typically represented by Greek letters, alpha, mu, right? And whenever you have variables that are describing statistics for a sample, they're going to be Roman numerals. X, A, B, S, right? So here we go. So just one more time here. Mu, okay, and then X bar. Mu is the symbol for population mean. X bar is the symbol for sample mean. Okay, so let's do this example here. So we're finding a sample mean. So we've got, I'll pause a moment, pause it, read the example. Okay, so how are we going to do this? We need to find the mean of these values. So it's very simple. You should have your calculator out. And in your calculator, you're just going to add up the numbers. So you're essentially going to add these numbers up. Okay, so what do you get when you add these numbers? So it's 872 plus 432 plus 397 plus 427 plus 388 plus 782 plus 397. You should get 3695. Okay? So, x bar is supposed to be the sum of your values divided by n. So we just found that the sum of our values, of our data entries, 3695. Now what is n? N is supposed to be the number of entries that we have. So let's count. 1, 2, 3, 4, 5, 6, 7. N is equal to 7. So 3695 divided by 7, that's approximately 527.9. The last thing we want to do is put units on. So remember the units up top dollars, because each of these numbers, right, the prices in dollars for a sample of round-trip flights is listed below. So if we add up a bunch of dollars, we're going to get dollars, right? So dollars divided by just a number is going to give us the unit of dollar. So our mean is, the mean price of the flights is about mean price of the flights is about $527.90. Okay. So should be pretty okay there. Now let's talk about the second measure of central tendency. That is, remember we have the three most popular ways to describe the center of data: mean, median, and mode. Okay, so actually let me go back here and say a little word again about
it's
this.
2045.
Thank you. Okay, so what does this mean, this $527.90? Another way to write this would be to say a typical flight costs $527.90. Okay, because remember, these are flights, round-trip flights from Chicago to Cancun. So a typical flight, round-trip, costs about $527.90. Notice that there's not one single flight that actually costs $527.90, and that's okay, right? But what we're saying is, if we had to pick one number in the entire world to represent the cost of a round-trip flight, we would pick 527.90 based on this data here. Okay, so now moving on to median. Now, median is a little different from mean. Here's what we do for the median. First thing you want to do is you want to take your data entries and put your data in order. Then you find the middle of your data, okay? The middle point. So here's how I like to remember about the median. When you're driving along a highway, right, so you're driving along a highway, you're supposed to stay off the median. You got it. So cars are going this way and cars are coming this way, and you're supposed to stay off the median, right? Why? The median is in the middle. Okay? So when we're finding the median of a data set, we're finding the number that's in the middle of the data set. And in order to find the number in the middle, you have to, step one, put the data in order. Students always forget to do that. Okay, put the data in order, in ascending or descending order, doesn't matter, but put it in increasing or decreasing order, doesn't matter. Okay, put the data in order and then figure out what is the middle number. Okay, so here it measures the center of an ordered data set by dividing it into two equal parts. So what are the two equal parts that you're dividing it into? You're dividing it into less than the median, greater than the median, right? So because the median is in the middle, when you take your data set, you're breaking it into two parts, and the two parts are equal. Now, notice here, if the data set has an odd number of entries, the median is the middle data entry. However, if the data set has an even number of entries, then the median, there is no median. There's no middle. So for instance, suppose you have a data set with 4 entries, right? And we put them in increasing order. How do you tell what the middle number is? There isn't a middle number. So what you do is you take your two middle numbers and you take the average of those two middle numbers, right? So in an even number, if you have an even number of entries, the median is the mean of the two middle data entries. Okay, let's go ahead and do an example. So pause, read this example, pause, try to do it, and see if we come up with the same answer. All right, so we're working with the same data entries that we had before. These are a sample of round trip flights. So let's figure out some beginning statistics here. What is in 1, 2, 3, 4, 5, 6, 7? So we have 7 different airfares, okay? And we want to find the median of the airfares. So the first thing I'm going to do is I'm going to put the data in order. So step 1 is to put the data in order, right? Order the data. So what does that mean? I'm going to put the smallest. It looks like the smallest is 388. Then the next biggest is 397. Then the next biggest is, oh, I've got another 397. Okay. And then I have 427. Then 432, 782, and 872. All right. So now that I've put the data in order, I just need to find the middle one. Here's how I find the middle one. I cross off the first and the last until I get to the middle. So my middle is 427. So the median price is $427. All right. So notice that someone could very well say an argument could be a typical cost of a flight is $427. And what's their reasoning? The reasoning is based on the sample that we have, this sample of 7. 3 are higher and 3 are lower than 427. So this number of 427 is taking the data and splitting it in half, right? So these 3 are more expensive, and these 3 than the median, and these 3 are less expensive. And notice that it's okay to have a different answer for what's a typical value, right? So when we were working with the mean, we said a typical flight costs $527.90. Now over here, we're saying that a typical flight costs $427, right? So this is, again, a reminder that statistics is different from the math that we're used to, where there's only one correct answer. Here, if you were to ask, what is the typical cost of a round-trip flight from Cancun to Chicago, both of these answers are valid, right? There's a valid argument to say 427 is a typical cost, and there's a valid argument to say that 527.9 is a typical cost. Okay, let's do another example where we're practicing finding the median. Now for this one, it says that the flight priced at $432 is no longer available. Womp womp. We waited too late. $432 is not an option. Okay. What is the median price of the remaining flights? Okay, so what we're going to do, we're going to do the same thing we did before. We're going to order the data. We'll get 388, 397, 397, 427, 782, 872. Okay, now I'm going to try to do my little trick again where I just mark off the outer and the inner. Oh, wait a minute. I've got 2 in the middle. So my median is going to be the average, right? It's going to be the mean of the middle 2. So it'll be 397 plus 427 over 2, which is 397 plus 427 over 2, which is 412. All right. So by dropping, if 427 is no longer available, right, the median drops to 412. Okay, and again, our units are $412. Okay. All right, let's look at our last measure of central tendency, which is the mode. Okay, so the mode is the most popular. That's the way I like to think of it. The mode is the most popular. Most popular entry, data entry. When do we, as a society, use the mode as a measure of central tendency? Elections, right? So anytime an election is based on the majority, you're basically saying we're going to use the mode, okay, to say, what's a good representation of what the people want? Let's use the mode, the most popular response. Okay, so it's the data entry that occurs with the greatest frequency. You could have lots of data sets don't have an entry that's repeated, right? So it's just a whole bunch of, no number is repeated. Lots of times when you're collecting, say your data, you're collecting websites or you're collecting, website addresses for whatever reason, or you're just a list of websites that people visit after they visit your website. You may or may not have a repeated entry in that data set, right? If you have no entry repeated, then the data set has no mode, okay, because you can't pick everything to be a mode. If you've got two different entries that occur with the same greatest frequency, then they're both the mode, and you call your data set bimodal, okay? Let's do an example here, finding the mode. So let's see here. So the prices in dollars for a sample of round-trip flights. Here we are again, still going from Cancun to Chicago. We want to find the mode. What's the most popular price? It is, what was it, $3.97. So we can tell already that the mode is going to be $3.97 because it occurs twice and nothing else occurs twice. All right. Let's do another example. Suppose at a political debate, a sample of audience members was asked to name the political party to which they belong. Democrat, Republican, other, and no response. What's the mode of the responses? What's the most popular response? Most popular response is Republican. So the mode is Republican. How do we know that's the most popular? Because it occurred with a frequency of 56. Here's another question. How many people responded to the survey? How many people are in our sample? Remember, our formula for N is to add up the frequencies. So we would need to add up 34 plus 56 plus 21 plus 9, which is 120. Right? So out of 120 people that voted, 56 said that Republican best represents them. No other political party was more popular than the Republican political party. So the mode is Republican. All right. So now let's talk a little bit about comparing the mean, the median, and the mode. Like we said, all three are valid arguments for describing a typical entry of a data set. There are some advantages and disadvantages of using each one. So the advantage of using the mean is good because it takes into account every entry in the data set. So it's like every single entry has a voice, okay? No one's left behind. Here's a disadvantage. You can be, if you use the mean is sensitive to outliers. So means are sensitive to outliers. What does this mean? This means that if you have an outlier, that is going to skew the mean, right? Perfect example, income in the United States, right? Or wealth in the United States. If you were to say, what is the typical amount of wealth of a person in the United States? It's going to be greatly skewed because you have a few people, right, relatively few, that have, like, right, so much money, and like everyone else is like over here, clustered over here, right, between $0 and $20,000, right? So everyone is clustered over here, but if you've got some people that are billionaires, it's going to skew the average so that the average is going to look like it's more like, I don't know what, but that'd be a nice little project to do to see how how they talk about that 1%, the 1%ers? How does that skew the mean of, the mean wealth? So if you're looking at, if you wanted to describe,
It's 21 hours.
thank you. If you want to describe typical income or the typical wealth of someone in the United States, what you're trying to do is going to determine whether you use the median or the mean or the mode, right? So if your argument is, hey, things aren't so bad, everyone's doing great, you say, look at the mean. Why? Because with the mean, you could say on average, people in the United States earn blah, 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 blah. That's so much more than people in the whole world, right? You want to use the mean because these billionaires are going to bring your mean up, right? So that your mean is going to be a lot higher. If, on the other hand, your goal is to say, hey, things need to change, things are not good, people are in poverty, people aren't earning enough, then you would use the median. And you would say, oh man, look, the median is somewhere over here, the median is so low. So you kind of get the idea about how you can make different arguments based on your motive if you understand statistics. Okay, so let's work with this concrete. This is just a little small concrete example for us just to practice comparing the mean, the median, and the mode. Now, so pause and read. Whatever. Okay. So the first thing we want to do is we want to find the mean, median, and mode. Okay, so to find the mean, we're just going to add up, is this of the sample ages of a class. So the sample ages, so our mean x bar is going to be the sum of x over n. So what's the sum of x is going to be 21, 2, 3, 4, 5, 6. So I actually have 6 20s, 1, 2, 3, 4, 4 21s, 1, 2, 3, 3 22s, 1, 2, 3, 4, 4 23s, 1, 2, 2 24s, and one person who's 65 in the class. And now how many people are in the class altogether? 1, 2, 3, 4, 5, 6, 7, 7, 14, 15, 16, 17, 18, 19, 20. 20 people in the class. What is that when we add that up? So it'll be 120 plus 84 plus 66 plus 92 plus 48 plus 65. 120 plus 84 plus 66 plus 92 plus 48 plus 65. 475 divided by 20. 23, 23.75. Okay, 23.75 years. So that is the median. Sorry, that's the mean. What about the median? Luckily for us, the data is already in increasing order, right? So the data is already ordered. So we just need to find the middle. So I'm gonna cross off. I've got 2 in the middle, and the mean is going to be 21.5. The median, sorry. So let's see here. Median is going to equal 21.5. And the mode is the most popular response. So what's my mode? Now, 20, 21, 22, 23, 24, and then 65. So I had 6 people for 20, 4 people that are age 21, 3 for age 22, 4 for 23, 2 for 24, and 1 for 65. So my mode is 20. So here's a question. If you had to say what is the typical age of a student in this class, which number would you use? Is 20 the typical age? Is 21.5 a typical age? Or would you say 23.75 is the typical age? Well, here's the deal. So the mean takes into account every entry, right? But the mean is also influenced. Do you see how that mean is so high? The mean of 23.75. You actually have a little graph here. So this mean, the mean is right here, right? 23.75. The reason why the mean is so much higher than the median and the mode is because it's taken into account the fact that someone in the class is 65, right? So that's pulling that mean up. So the mean is higher than it would have been if it didn't take into account the outlier of 65. The median also takes into account every entry. How does it take into account every entry? Because you have to have all of the numbers, put them in order, and then you find the median, right? So if you remove a number, right? So imagine if we were to remove a number, say we eliminated 20, that would change our median. So our median would now be different, right? So that's how the median takes into account every entry. And the median is not impacted by the outliers. So medians aren't sensitive to outliers because imagine if you had someone in the class who was 1,000 years old, right? That's really not going to change the median that much because the median doesn't care about extreme values. The median only cares what's the middle of the data. Okay. Now, in this case, the mode exists, but it doesn't appear to represent a typical entry. Why? Because the mode is the youngest, right? So the mode is 20, and 20 is the youngest. So if you said that the typical person in the class is 20, I mean, is that really all that accurate? Because most people in the class, can drink alcohol. Most people in the class are over 21. So if you go with 20, and also you have someone in the class who's 65, and some people that are 24, 23. So when we look at the graph, we can see that between the mean, the median, and the mode, it'd be best, right? So between the mode, the median, and the mean, so the mode is here at 20. The median was 20. What was the median? The median was 21.5, and the mean was 24. The best is to go with the median because the median is kind of in between the mode and the mean. Okay. So in this case, it appears that the median best describes the data set. All right. Now let's get into a brand new topic. Brand new topic is called weighted mean. This is something, as I said at the beginning of the video, something that we've actually been doing before. You've done it before whenever you calculate your GPA. So weighted mean is a mean of a data set whose entries have varying weights. So you have a data set and you've got data entries, but not every entry counts the same, right? So not every entry weighs the same. So here's our formula for the weighted mean. Let me go ahead and here's our formula. Our formula is X bar, the sum of, so you have your weights, you have your values, and then divided by the sum of your weights. Okay, so let's look at this example. Take a moment to read this example. All right, so here's what we want to do. We essentially want to use the formula. We've got our formula that X bar is equal to the sum of X times W over the sum of our weights. So what we need to do is figure out what's X and what's W. So let's look at the source. X is going to be our score, and then W is going to be our weight. Okay. So we can make a little table here. So now what are the components for the grade? Okay. We can just put our scores here. So the scores that we were given, 86, a 96, an 82, a 98, and 100 on the homework. Good job on that homework. So this is the homework. Lab was 98. The 82 was the final. 96 was the midterm. And then 86 was the average on the tests. Okay, and then we're told that tests count 50%. So tests count 50% of the grade. So the weight is 0.5, right? 50%. Same thing as 0.5. Same thing as 1/2. Midterms. How much do midterms count? Midterms are 15%. So let's change that percentage to a decimal. Final exam is 20%. The labs are 10%. And the homework is just 5% of the grade. All right. So now, let's see here. The next thing we want to do is let's come up with X times W. So what we need is we need to add up the scores times the weights. So 50% of 86 is going to be 86 times 0.50. So that's going to be 43. And then we need 96 times 0.15. That's going to be about 14.4. 82 times 0.20. That's going to be 16.4. 98 times 0.10 is going to be 9.8. And then 100 times 0.05 is just going to be 5. All right. So once we have this, we should be able to add. Let me add a page after. Add a page below. So we should be able to add, copy, paste. Okay. So my sum of x times x times w is just going to be, I need that to be 43 plus 14.4 plus 16.4 plus 9.8 plus 5, which is equal to 43 plus 14.4 plus 16.4 plus 99.8 plus 5 is going to be 88.6. Okay. And now I also need my sum of W because my formula, remember my formula, here's my formula. Let me copy my formula. Copy. Paste. Okay, good. So my sum of W, so let's go back here. What are my weights? Copy. Paste. Ooh, that's crazy, huh? Resize.
It's 21:15.
Okay. So the sum of my weights, I just need to add up 0.5 plus 0.15 plus 0.2 plus 0.1 plus 0.05, and I should get 1.0. 1.00. Because remember, everything adds up to 100%, and 100% is 1. So now my x bar, which is my sum of x dot w over sum of w, the sum of the score times the weight divided by the sum of all the weights is going to be 88.6 over 1, which is 88.6. So that student did not get an A because their overall average was 88.6. So, and they needed a 90 to get an A. All right. So notice that it's really important. The weights, because the person had 70% of their grade came from scores that were less than an A, right? And then 30% of their grade came from scores that were more than, that were higher than 90%. So that 30% wasn't strong enough to pull, those other scores up to an A. So that's what we mean by a weighted mean, right? Because you might say, hey, this person got 100 on the homework and they got a 98. Man, they knocked it out the box. And they did, but those components of the grade don't weigh enough to compensate for getting like a B minus on the final and a B on their tests. All right. So now let's talk about another topic. This topic here is the mean of grouped data. Okay. So if you have a frequency distribution, you can talk about the mean of the distribution. What's the difference between the mean of a distribution and the mean of a data set? Well, if you have a data set, you can create a distribution, right, from that data set. And you can find the mean of the data set. Now imagine if you have only a distribution. So you don't have your original data, you just have the frequency distribution of the data. In this case, the best you can do is approximate the mean because you don't know the original data. So what you do is you use midpoints of your frequency distribution classes as representatives of your original data. Okay, so here we have, we've got kind of a guideline for how to find the mean of a frequency distribution. First thing you do is you need to find the midpoint of each class. After you find the midpoint, you need to find this right here, the sum of the midpoint times the frequency of that class. Then the next thing you need to do is find n, the sum of the frequencies. This part right here should be really easy. Okay, and then lastly, you just plug this into your formula. Okay, so your numerator is going to be the result of step 2, and your denominator is going to be the result of step 3. Divide them, and you get the mean of your frequency distribution. So let's do an example. In this example, we are trying to approximate the mean number of minutes that a sample of internet subscribers spent online during their most recent session, right? So the issue is, how long on average did did a typical internet subscriber spend online on their most recent session? And you don't have the original data points, you just have a frequency distribution. Notice for this distribution, we are very happy because we've been given the midpoints already. So that's going to help us out because step 1 is already done for us, right? Because we already have the midpoints of each class. All right, so let's go ahead and fill this out. So the next thing, step 2 is to compute the sum of instead of the weights, we want the midpoints times the frequencies. So I need to know, what is 12.5 times 6? 75. So let's put here, this is going to be x times f. So we'll have 12.5 times 6 is going to be 75. And now 24.5 times 10 is going to be 245. 36.5 times 13 is going to be 474.5. Okay, 48.5 times 8, 388. 60.5 times 5 is going to be 302.5, so 302.5. 72.5 times 6 is going to be 435. And then 84.5 times 2 is going to be 169. So now when we add up the sum of our midpoints times the frequencies, we get 2089. Okay? And step 3 is to compute N, which is the sum of all our frequencies. So the sum of our frequencies is, we just need to add these numbers here. So 6 plus 10, that's going to be 16. So plus 13, that's going to be 20. 29 plus 8 is going to be 37. Plus 5 is going to be 42, 48, 50. All right. So when we add these all up, and I just kind of did it in my head here, but what you're going to be doing is you want to just add up all these numbers, right? With 6 plus 10 plus 13 plus 8 plus 5 plus 6 plus 2, and you should get 50. Okay. So now we should be ready to give our approximation of the weighted mean. So it should be 2089 over 50, which is about 41.8. And so now what are our units? Well, let's see here. Approximate the mean number of minutes that a sample of internet subscribers spent online. So this right here is, so the units of our class are going to be minutes. Right? So they had 6 people that were online somewhere in between 7 and 18 minutes. They had 10 people that were somewhere between 19 and 30 minutes online, right? And it looks like the longest people were online. No one was online more than 90 minutes. So our units are going to be minutes. So the average length was 41.8 minutes. All right. So now the last thing we want to do, the last thing I want to share with you tonight or this afternoon is a little bit about the shape of distributions. Now, symmetric distributions, very, very, um, very, very easy to tell if a distribution is symmetric. For example, this, oh, let me take that off. Symmetric distribution could be something like this. This is a distribution that is symmetric and bimodal, right? Because we've got a mode. Looks like here's one mode and here's another mode, because remember up top is our frequency, right? So what is the most popular is whatever this value is here. So this is bimodal and symmetric. If you have a distribution that is unimodal, meaning one mode, unimodal and symmetric, then we're looking at something like this, bell-shaped, right? Symmetric. The key thing for symmetric is that the mean, the median, and the mode are the same. Okay. Uniform. This is another way to describe distributions. Uniform, it's also called rectangular distribution, just means that all of the entries have approximately the same frequency, right? So it's like your responses are uniform, right? If every entry has approximately the same results, the same frequency, it's uniform. Please notice that this is also symmetric. So uniform distributions are also symmetric. The mean and the median are going to be right in the middle of the range of your data. Okay, now here we go. We're talking about left skewed and right skewed. So left skewed means that left tail is a little bigger. I don't know if you can kind of see, you can drag it out as much as you want. This more extreme, left skewed, right? It's got a really long tail. And in a left skewed, the mean, so let's kind of blow this up. So in a left skewed distribution, the mean is less than the median and the mode. Now, why is that? That's because, so the mean is less than the median and the mode because you have a lot of little small values, right? And these small values are bringing the mean down. So imagine you've got your symmetric, right? So this is your symmetric distribution. And typically your mean, your median, and the mode are all here. But now if I add a bunch of values that are small, then my mean is going to be dragged over. So my mean is going to end up being smaller. Because remember, the mean is going to be impacted by outliers, right? So that's another way to kind of see it, is that the mean is going to be brought down to be smaller because it's impacted by these outliers that are occurring from this tail, this left tail. Okay, and then similarly, right skewed. Right skewed is very similar. The mean is going to be greater because you have a lot of high values. Right, so if you've got these high values, it is pulling the mean up. Okay, so in summary, we've found the mean, the median, and the mode, right? Those are 3 different ways to describe the center of a distribution, 3 different ways to describe a typical value of a data set. Okay, we talked about weighted mean of a data set. Do you remember the formula? Weighted mean, do you remember the formula? The formula is x bar equals the sum of x times w over the sum of w. So here the w, these are weights, and these are the values. And we found the mean of a frequency distribution. Do you remember the formula for the mean of a frequency distribution? it was very similar. The mean of a frequency distribution, x bar, we're approximating it, so we could even do this. X bar is approximately the sum of x times f over the sum of f. Now here, f is a frequency, and x is the midpoint of your class. Okay, and then this bottom part is another way to write this, is just n, which is the total number of your sample. Okay, and then for the mean, we were introduced to some new notation. Okay, for the mean, notation wise, we have x bar, right, is the sample mean. And we have, do you remember the symbol for population mean? Do you remember how to pronounce it? Mu. Okay. We don't have notation for median, and we don't have notation for the mode. The mode is what's most popular. Most popular. It's the data entry with the highest frequency.
It's 2130.
And then the median is the middle value. Right? And remember, if we have two middle values, then you take the average of the two middle values. Okay, and then lastly, we described the shape of a distribution as symmetric or uniform, right? Everything that is every distribution that's uniform is also symmetric, but some distributions are symmetric and they are not uniform. And then we discussed left-tailed, right-tails, left skewed, right skewed, and what happens to the mean and the median when you have a left skewed versus a right skewed versus a symmetric distribution.